Oh, hi there, you're back. So now we did our job. We produced immense and large data sets of scientific data. And now we want to bring the data into our scientific community. So therefore we need a format, a very simple format, which others can use to analyze our data. So therefore, for example, in VLBI, we have these international corporations in the International VLBI Service for Geodesy and Astrometry, and you find a lot of these different data, let's say data archives, where you can get data from, for example, ncdisp, and you will find there a lot of these files. And if you go into these files, you will always meet special extensions. For example, if I zoom in, you will see these NC files, and this stands for NetCDF. So a very famous in meteorological communities, in geoscience communities, in geodetic communities, a very essential format is NetCDF, NC. And therefore we will have now a look into this. So follow me. Welcome again to the next lesson. Today we want to have a look into another data format which is very often used in geoscience fields. And we talk today about NetCDF. NetCDF is a very famous format because it's so easy. It's a library in principle which you include into your software, and then everything is stored automatically in a form of tables, which is stored binary, and you don't have to take care on how it is stored and how you have to read it. You just use a library and you read in the stuff, and you can directly work with this data, and therefore it's a very, very nice utility. So today I want to show you the few things. What is NetCDF? I don't give you a detailed explanation of the internal parts of NetCDF because it's a large description, and you find it in the standardization documents. I want to focus on this here, onto working with NetCDF, because this is what you have to do. You have to get data from NetCDF, you have to save data to NetCDF files, and I want to focus on to working with Matlab. So we will use the Matlab functions to read NetCDF, and you will see how easy it is. There are just 4 or 5 different Matlab functions which you can use to get NetCDF files. So we want to create variables in NetCDF, we want to write variables to a file, we want to read variables from a file, and we want to define attributes, special additional information or meta information about our data. So let's start with what is NetCDF. NetCDF is the network common data format, and you find it in this web page here, and also the documentation about the user guide you find there at Unidata. So NetCDF was developed and is maintained at Unidata. Unidata provides data and software tools for use in geoscience, education, and research. Unidata is part of the University Corporation for Atmospheric Research, UCAR, and the community programs. And Unidata is funded primarily by the National Science Foundation. So it's a real format from scientists to scientists. So therefore, let's have a look into what is NetCDF. So the NetCDF network Common Data Format is an interface to a library of data access functions to store data in a specific file format. This file format stores data in multidimensional arrays, which are called variables. NetCDF is mainly used and optimized for the scientific data sets, so that many geoscience data are often stored in the NetCDF format. NetCDF data are self-describing, so you have additional information given by the naming and by the additional attributes, so that metadata inform about units, timestamps, and so on. NetCDF is portable over different platforms, so that data types are coded. So the binary types are really coded in the file format, so that you can use it on different platforms. And NetCDF is scalable, so that direct access is possible. These direct access methods, so remember the course about these access methods, and therefore it allows to read blocks of data without reading the whole file. So you can jump into a special set of data and you don't have to read the whole file. So what is the NetCDF, Network Common Data Format? So what you have here is, you have here a file, a NetCDF dataset. And this NetCDF dataset consists first of all of variables. These variables are the real data of specific data types in form of arrays. So you have arrays, one or two-dimensional or multi-dimensional arrays with a predefined dimension, and they have optionally additional attributes. The additional attributes are something like meta information. Usually you define these dimensions in a fixed way, so they are fixed, so you cannot change it later on. In new formats you have more variable lengths of the data sets, and then you define the dimensions of the data sets. So the variables are in principle the names where the data container is given, and then you have the dimensions. The dimensions are naming and fixing of the shape or the dimension of this set. So this defines that you have 10 cross 10 elements, for example. So for example, you have x elements in the x-axis. You name this dimension also, so you can give, for example, time or length or range. So you can define or can name this dimension as you want, and you define also the length, and the size cannot be changed anymore. So if you fix it, then it's fixed, so it's not possible to rearrange. So you have to create a new one, have to copy the whole stuff into this new one. Okay, and in addition to that, you can have these attributes. So variables, dimensions, and attributes build this NetCDF file. So what are the attributes? The attributes are in principle meta information. Meta information, for example, like kilometers per hour, so units, or other informations like a special timestamp, so that you know, okay, the data are from date July 21st. Okay. So there's one specific type of variable. If the variable is a one-dimensional array and has the same name like the dimension, then it's called a coordinate variable. So here you have it. So it's called a coordinate variable, so that the size is defined that the variable is the same like the dimension, usually for one-dimensional arrays. So let's work with this data. So we come now to this work with NetCDF, and what we want to do is now we want to create, first of all, variables. So we want to create variables where we can store data in our files. So how does it work? You have variables and you need dimensions. So these two things you have to define so that you can store or create variables, and we do this with Matlab. So what are variables? Variables are names with alphabetic characters, numbers, and underscores, but not with white spaces. So it's like in normal computer language, you have one special identifier. you have to begin with an alphabetic character or with an underscore, not with a number, and they are case sensitive. So these things are the names here of these variables. And then how do you create these variables? So if I jump to here, you see that the variables look like this. You create with one single function. You create the file, you name the file, and you need this file name for each command. So you create this file, in my case, my test, nc. Usually nc is the extension which gives you the information that is a NetCDF file. Then we name this variable, in my case temp or temperature. Then you define the dimensions, which is this one. So I directly name the dimension x and y. So for temperature maybe it doesn't matter or give not too much sense. It would be possible to say time and, for example, sensor ID, so that you have directly a name for the dimension, and then you define the length and the or the number of rows and the number of columns. And then finally you define the data type, in my case double, for example. So in this case I have a 100x10 table or array or matrix if you want to think in Matlab versions, and this creates then a file where you have this in. So if you read with a special function the content or the description of this file, then you will see that the source is my test nc. The format is a special format in NetCDF. There are different versions of NetCDF. The dimensions are x and y, and you have the variable temp with this size using this dimension and this data type. So let's have a closer look into this. What do you have now? You have now a matrix with x cross y elements. It's called temp in the file NetCDF, and each element is of type double. So what are these special formats? You can select between different basic formats. So the classic format here is a 32-bit platform format with maximum size of 2 GB. So it's brought to this 32-bit scenario. And then you can have the 64-bit offset, where you have 60-bit platforms with maximum file size of 2 to the power of 63 bytes. So it's a huge, large file. And the interesting thing is that reading is still quite fast because of this binary format, and this directly jump to special sections in its format. So these direct access methods. And then you have here different data types. So if I show you the data types, you can select double, single, int64, unsigned int64, int32, unsigned int32, int16, unsigned int16, int8, unsigned int8, and character. So these formats you should know from the lessons about the binary lesson or about the binary systems, because we use this for the reading also of altimetry data. So it's the same what you know. So this number defines the number of bits, and the integer defines that it is an integer, double or float defines that it is a floating point number, and u defines that it is unsigned. Unsigned means there is the complete bit sequence used for the number, that you have just the positive range. And finally, you can use infinite to specify an unlimited dimension, and this is what is now new in this these modern formats, where you have NetCDF4 format, for example. You can have any unlimited dimension in any order. In all other formats, you have to use fixed sizes, and then you can have unlimited number of, for example, rows. So only the last dimension can be unlimited, so that you can have a continuous set of data, but you have a fixed, let's say, number of columns, for example. So only one dimension is unlimited or optional, the rest must be fixed to a specific number. Only in this NetCDF4 format you can set it in any case unlimited. The normal way is now, if you produce a variable, we have this variable now available in the file, and then you have to write data into this variable. So you have to write this variable. How can we do this? So what do? We have a variable and we want to write values into this variable. So this is the way. Again, it's just one single function which you use. So I jump to here again. A single function which you use, and it's called ncwrite. So again, all of this function dealing with NetCDF is with this additional header nc, and you write ncwrite, and then you name again the file which you want to write or which you want to use, where you have this variable created. Then you name the variable and you set, or you hand over the matrix or the vector which you want to send in. This vector must exactly fit to the size of the variable, or you have to use pieces of it. I will show you later how to do this, but you create exactly the size of the variable. If you use it in this method and this version, then it's exactly the size which you used for the definition, for the creation of this variable. So again, the file name is always the identifier for the individual file, and then you name the variable which you created, and you hand over the input arguments, which is a matrix or a vector of the same size which you used for the division definition, of the individual variable size. Okay, so therefore what happens if you do this? It writes the file again, and then you have the binary data in your file. So what you get now is you have now the same matrix as before, so the same stuff, and now data are filled in. So for example, in my case I used randomized data, so data are now in this file. Two functions. So the first function is to create, and the second function is to write the variable content. So what you also can do, I told you that it's not completely necessary to write always the whole stuff, because you can directly jump into blocks of data sets because of this index or of this direct access methods. And therefore, for example, if you just have a small portion of your data, like in this case 3 lines of the data sets, then you can use ncwrite again with the same file and variable names, and then you can set just the test data from 3, 1, which means it's the starting index of x and the starting index of y, and then the whole stuff is written to the file. So with this case you can just update blocks or small portions of the data, so that you don't have to write the whole data set all the time. So with this nice tool you have a really helpful access or update access to individual pieces, and this is why scientific data, or why it is used for scientific data, because it's so helpful if you have updates and new processed data sets. So what does it do? Just to show you again the sample, you have now 3 lines of the data which you replace from the starting index 3, so it's the 3rd line, and starting index y1, which is the 1st column. So it replaces all of this stuff. The dimension must then fit again, of course. So if you just replace 4x4 elements, then you have, of course, used the correct starting indexes and also the correct input data. Okay, so next, today we are quite fast because NetCDF is so easy. So working with NetCDF, we created a variable, we wrote a variable, so we created our own file with a first variable, and now we want to read back this information again into our data processing mechanism. So how do we read back this information? So again, we have now the data in the file. So we created this file, and now we want to read it back to the user or to the processing utility. So again, it's just one single function. So this one single function is called ncread, and this ncread uses the file name, of course. Can be also a path, so a whole path through the location of the file, and then we use the variable name. So therefore you have to know which variable is in this file, or you use a special method which you will see later on to get the whole content or the whole description of the content. So with this you read in the data, and you will get then the variable and the values again in your Matlab program. So what we did, we wrote the data, and now we read the data back. ncreate, ncwrite, ncread. So again, what we do here, we have now this matrix in our memory, in our workspace. The same like with read, with write, we can do with read. So we can just read a portion, a small piece, a small section of our data. And this is done with an additional attribute. You define the start index of the first dimension and the start index of the second dimension, so x and y, and then you define the index count. So you define how many elements should be read. So in my case, for example, I define that I want to read from my test and see the variable temperature, but I want to start at line 90 and column 1, and I want to read the next 3 lines completely, the 10 columns. So what I get back is that I just read 3 lines at this position, and this is this very, very sophisticated and very fast method, because we cannot jump to any position in our data, and we will read it with the methods of binary reading, which is quite fast, and we will have a really helpful and very comfortable way to deal with data. And you don't have to think about the format. So this is the great thing. You just use the library, and the library is available for Python, for C, for Matlab, for all of the other languages, and you just use it, and you just process the data. You don't have to focus on two formats, you don't have to write on formats, you just use these functions, and then you process the data. So what do you do now? For example, if you don't know what is the content of the file. So for example, you have now a binary file. Remember what we had with our altimetry data. If you just get the binary file, it doesn't help you too much. So we needed this description. So therefore, this is the big disadvantage in binary formats, and here's almost the same. But of course, we have here a solution, because there is a method or a function which checks the content and gives you a readable version, a readable description of what is the content, what is part of this file, what do you have in as attributes, as variables, and as dimensions. So, and therefore you can use a special, very simple function to get this information. So I have to jump to the left, and you will see it's quite simple. You have ncdisplay or ncdisp, and then you just hand over the file name as argument, and what you get back is exactly the description of what is the part of. You maybe remember I had it already on this side, because I wanted to show you if you write something that it looks like this then in the file. So this is the information what you get back. You get back the name of the source, you get back the format, version, the dimensions, and the variables. So with this, it's quite simple that you know what is inside of this file, even if you get a file without any description. So it's self-explaining. And this is the big advantage of this. You have the binary format and the self-explaining version where you can get a readable explanation of what is the content of this file. Okay, so therefore it's really a nice format and a nice library. So you see today NetCDF is really too easy maybe. So you see we're quite fast today. So creating, writing and reading files, remember ncreate, ncwrite and ncread and ncdisp display. Last one is we want to define additional attributes. Additional attributes, remember, are meta informations like units, like kilometers per hour, things like that. Okay, so therefore let's have a look into this. So now we set up the whole set. So we set up the whole set of variables where we use dimensions and we add optionally, you see this, it's an optional part here, attributes to this. Again, it's just defined with a very simple function. So if I jump again to here, you see it, you write ncwrite attribute. So you remember ncwrite was the normal content writing. ncwrite attribute now sets an attribute in this file according or which belongs to the temperature. So you set an attribute for temperature variable. And it's not a global variable, it's a local variable defined for this special variable, or a local attribute defined for this special variable. And you define it as unit with degree Celsius. So in this case, you name the attribute and then you give a value for this attribute. And how does it look like if you do it in this way? Then you will get here the same style again with ncdisp. You will get this information, and now you will have these additional information attributes, and these attributes has unit equal degrees Celsius. So you have now a very local additional possibility to set in metadata all additional informations which are helpful to identify, to interpret, to process the real data. So what you can also do is, we defined here now a local variable, but what you can also do is you can define a general common variable. So it's called a global attribute, and this global attribute is defined here in the general part of the file. And you can do this if you see it here, if you don't name the variable, if you just set the root element, so this slash, if you just set the root element, then you define that it is a global attribute. So this global attribute does not belong to any individual variable, it's just a general description. For example, in my case, the date of the creation. So what I do is I create the date of the creation and I set the current date. In my case, date string now returns this date string. Okay, so therefore you have now a possibility to create variables, to define the dimensions of the variables, and to add additional information, meta information, to this variable. You can set local attributes, local meta information, or global meta information for all variables or for the whole file. So remember, ncwrite, ncwrite attribute, ncreate, and ncdisplay, and of course ncread. So these functions help you to deal with large data sets, scientific data sets, and this is quite nice. So if you want to process this data again, you have of course also the possibility to get attributes of a variable back from your file, and this can be done with ncread attribute. So it's the same again like with the write and with the read of variables. So ncread attribute from my test.nc, and then if you define temp, then you will get the temp variables and also according attributes, and then you define the attribute unit. So in this case, temp and unit, and then you get back the information here, degrees Celsius. So this is what you get. It's a character array or a small character sequence with dig Celsius or dig C, degrees Celsius, as content. So if you use again the slash instead of temp, then you get the global attributes again. And in principle, that's it. So you don't need more of that. So this is everything what you need. So NetCDF is quite simple and quite helpful, and you don't need more information. So therefore, in the tutorial, we will deal a little bit with and we'll play a little bit with this data, so that you will see some samples. And what I can show you now is with a real data set, which we have seen in the intro, to read out the meteorological information about a special VLBI session, so that you see it directly in a sample, how to deal with this data. So let's have a look into this. So maybe you remember I made a download of this data set from the November 30th in the year 20. So it's last year, from the 30th. And I selected here the WetSat 13N, which is the Wetzel antenna, the 13-meter north antenna. It's a small antenna here at the observatory. And here are all of the data. For example, azimuth elevation positions, system temperatures, time UTC parameters, and also the mat.nc. So this is within zipped file. So I copy this out and then I can directly work with it. I can have a look into this file with ncdisplay. So you remember ncdisp, and then the file is named mat.nc, and then I will get the information. So let's have a look. You see the source, you see the format, it's a classic format, you see the named dimensions. It's a little bit cryptic here, so it would be much better if you have directly names, but I think they're created automatically. And then you have the variables. You have stop, create time, created by. So for example, for create time, it would be enough to have an attribute. So it depends on how you or how the designer of this, let's say, content name this thing. The program, subroutine, the vgosDB version, because it's vgosDB, the whole set of data is in a vgosDB, and the geodetic observation system for VLBI. And you also have information about the temperature, the relative humidity, and the atmospheric pressure. So let's plot maybe the relative humidity. We have 442 elements. It's a single, let's say, a single column vector. So it's a vector, not a matrix. And the dimension use numstate scan. So it's this 442, the number of scans and or station scans, and then the format is double, and the attribute is the creation time. The definition is like this, and you have a special L code which defines a shortcut, for example, or acronym, an ID for this, and then you have no units here. So what you can do now is you can now just read this data, ncread, but again, this is not part of the NetCDF. This was defined by the designer of the data set. So they created these attributes and these variables. So it's very flexible, and you still use the same functions. So let's read the file relative humidity, or the variable relative humidity from mat.nc, and we read the relative humidity. And if we do this, we'll have the stuff in answers, and then we can plot ans, and we will get a complete plot of the data. So this was for 24 hours the behavior of the relative humidity at wet cell. And you see, I just used 3 functions. So, and you see, I just used 3 functions. So I used ncdisplay, then ncread, and plot answer. So that's it. And with this, we have now a very helpful utility to deal with our different, let's say, very important and really sophisticated data sets. We'll play a little bit in our tutorial. You saw that today it was quite fast. So it's one of the, I would say, easiest lessons, but it's really essential that you know what is NetCDF, because this format is really often used nowadays for different data sets in geoscience. So let's have a look in the tutorial, have a lot of fun with this, and we'll see each other. Stay safe, and we'll see each other again. Bye-bye.